So this is a demonstration of a NOR gate, and the idea of a NOR gate is that if at least one of the inputs are 1, then the output is 0. So if the inputs are these two buttons over here, the idea is that if at least one of them is pressed, then the LED should turn off. So if this one is pressed, or this one is pressed, or both of them are pressed, this LED should turn off. And the way this works is, I have this resistor connected to this entire row here, which means the same current is going through all this wire, and this LED, and both of these wires feed into one of the transistors, and the transistors themselves are connected to ground. Now, because neither of these transistors is receiving a voltage at their gate from the buttons, this is an incomplete circuit and this is an incomplete circuit, which means currently the only pathway that the electrical current can take is from the resistor to the LED to ground. But what happens is, if I press this button, the LED turns off, because now since there's voltage at this transistor's gate, the orange wire is connected to the small gray wire, which means that there's now a pathway of zero resistance from there's a pathway of low resistance from this resistor to ground. So the current flows through that instead of the transistor, instead of the LED, and the LED turns off. Similarly, if I click this button over here, it'll go from this resistor to this long gray wire to the small orange wire to ground, because the gate has voltage, so the source and the drain are connected, which means that there's just a path of low resistance. And then obviously, if I click both of these, the LED turns off as well, because now both of these transistors are connected to ground. So there's two pathways of very low resistance the current can take, and so the LED turns off because it receives no voltage and no current flows through it.